Arithmetic progressions. Introduction. You must have observed that in nature, many things follow a certain pattern, such as the petals of a sunflower, the holes of a honeycomb, the grains of a maize comb, the spirals on a pineapple and on a pine cone, etc. We now look for some patterns which occur in our daily to day lives. Some such examples are: Rina applied for a job and got selected. She has been offered a job with a starting monthly salary of Rs 8,000 with an annual income increment of Rs 500 in her salary. Her salary in Rs for the first, second, third years will be respectively 8,000, 8,500, 9,000. The length of the rungs of a ladder becomes uniformly wide 2 centimeters from bottom to top, seen in figure 5.1. The bottom rungs is 45 centimeters in length. The length in centimeter of a first, second, third, eighth rung from bottom to the top are respectively 45, 43, 41, 39, 37, 35, 33, 31. In the above scheme, the amount becomes 5 upon 4 times of itself after every 3 years. The majority amount in Rs of an investment of Rs 8,000 after 3, 6, 9 and 12 years will be respectively 10,000, 12,500, 15,625 and 19,531.25. Number 4. The number of unit square in squares beside 1 to 3 units, see figure 5.2, are respectively 1 square, 2 square, 3 square. Number 4. Number 5. Sakla puts Rs 100 into her daughter's money box when she was 1 year old and increased the amount Rs 50 every year. The amount of money in Rs in the box on the first, second, and third and fourth birthday were 100, 150, 200, 250 respectively. A pair of rabbits are too young to produce in their first months in the second and every subsequent months they produce a new pair. Each new pair of rabbits produce a new pair in their second months and in every subsequent months. See figure 5.3. Assuming no rabbits dies, the number of pair of rabbits at the starts of the first, second, third up to sixth month respectively are 1, 1, 2, 3, 5, 8. In the above example, we observe some pattern. In some, we found that the succeeding terms are obtained by adding a fixed number. In other, by multiplying with a fixed number. In other, we find that they are square of consecutive numbers and so on. In this chapter, we shall discuss one of these patterns in which succeeding terms are obtained by adding a fixed number to the preceding term. We shall also see how to find their nth term and sum of nth consecutive terms, and use this knowledge in solving daily life problems. 5.2 Arithmetic Progression. Consider the following list of numbers. Number first, 1, 2, 3, 4, 5. Number second, 100, 17, 14, and number third, minus 3, minus 2, minus 1, 0. Number 4, 3, 3, 3, 3. Number 5, minus 1.0, minus 1.5, minus 2.0, minus 2.5. Each of the number in the list is called a term. Given a term, can you write the next term in each of the list above? So, how will you write it? Perhaps by following a pattern of rule. Let us observe and write the rule. Number 1. Each term is one more than the term preceding it. Number 2. Each term is 30 less than the term preceding it. Number 3. Each term is obtained by adding 1 to the term preceding it. Number 4. All the terms in the list are 3. That is, each term is obtained by adding bracket or subtracting bracket close 0 to the term preceding it. Number 4. Each term is obtained by adding minus 0.5 to the term preceding it. In all the list above, we see that successive terms are obtained by adding a fixed number to the preceding terms. Such list of numbers is said to form an arithmetic progression. It's capital A and P. So, an arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except that first term. This fixed number is called the common difference of AP. Remember that it can be positive, negative, or 0. Let us denote the first term of an AP by A1, second term by A2, up to n term by an, and the common difference by t. Then the AP become A1, A2, A3 up to an. So A2 minus A1 is equal to A3 minus A2 is equal to up to an minus a and minus 1 is equal to t. Some more example of APR. The height in centimeter of some student of a school standing in the queue in the morning assembly are 147, 148, 149 up to 157. The minimum temperature recorded for a week in the month of January in a city arranged in ascending order are minus 3.1, minus 3.0, minus 2.9, minus 2.8, minus 2.7, minus 2.6, minus 2.5. The balance money after paying 5% of the total loan of 1000 every month is 950, 900, 850, 800 up to 50. The case prize given by a school to the topper of class 1st to class 12th are respectively 200, 250, 300, 350 up to 750. The total savings after every month of 10 months when Rs50 are saved each month are 50, 100, 150, 200, 250, 300, 350, 400, 450 and 500. It is left as an exercise for you to explain why each of these lists above is an AP. You can see that A, A plus D, A plus 2D, A plus 3D represent an arithmetic progression where A is first term and D the common difference. This is called the general form of AP. Note that in example A to E above, there are only a finite number of terms, such as AP is called a finite AP. Also note that each of these arithmetic progressions APS has a last term. The APS in example 1st to 5th in these sections are not finite APS, and so they are called infinite arithmetic progression. Such APS do not have a last term. Now to look about an AP, what is the minimum information that you need? Is it enough to know the first term, or is it enough to know only the common difference? You will find that you will need to know both the first term A and the common difference D. For instance, if the first term A is 6 and the common difference D is 3, then the AP is 6, 9, 12, 15. And if A is 6 and D is minus 3, then AP is 630 minus 3 up to. Similarly, 1 is equal to minus 7 is equal to minus 2. The AP is minus 7 minus 9 minus 11 minus 13 etc. is equal to 1 and common difference is 0.1, then AP is 1, 1.1, 1.2, 1.3 and so on. If A is equal to 0 and common difference is 1 into 1 by 2 and common difference is fraction 1 by 2, the AP is 0, 1 by 2, 3, 4 by 2, 6 and so on. If A is 0 and common difference, if A is 2 and common difference is 0, the AP is 2, 2, 2, 2 up and so on. So, if you know that A and D are, you can list the AP. What about the other way rounds? That is, if you are given a list of number, can you say that it is an AP and then find A and D? Since A is the first term and it can easily be written, we know that in an AP, every succeeding term is obtained by adding D to the preceding term. So D found by subtracting and any term from its succeeding term. The term which is immediately follows it should be sum from an AP. For example, for the list of number 6, 9, 12, 15, we are A2 minus A1 is equal to 9 minus 6 is equal to 3, A3 minus A2 is equal to 12 minus 9 is equal to 3, A4 minus A3 is equal to 15 minus 12 is equal to 3. Here the difference of any two consecutive terms in each case is 3, so the given list is an AP whose first term A is 6 and common difference D is 3. For the list of terms 6, 3, 0, minus 3, A2 minus A1 is equal to 3 minus 6 is equal to minus 3. A3 minus A2 is equal to 0 minus 3 equal to minus 3. A4 minus A3 equal to minus 3 minus 0 equal to minus 3. Similarly, this is also an AP whose first term is 6 and the common difference is minus 3. In general, for an AP A1, A2 up to AN, we have D is equal to AK plus 1 minus AK, where A, AK plus 1 and AK are the K plus 1 and K term respectively. To obtain D in a given AP, we need not find out of A2 minus A1, A3 minus A2, A4 minus A1 and so on. It is enough to find only one of them. Consider the list of numbers 1, 1, 2, 3, 5. By looking at it, you can tell that the difference between any two consecutive terms is not the same. So this is not an AP. Note that to find D in the AP 630 minus 3, we have subtract 6 from 3 and not 3 from 6. We should subtract the K term from the K plus 1 bracket close term even if the K plus 1 term is smaller. Let us make the concept more clear through some example. And term of an AP 5.3. Let us consider the situation again, given in section 5.1, in which Reena applied for a job and got selected. She has been offered the job with a starting monthly salary of 1,000 with an annual increment of Rs 500. What should be her monthly salary for the fifth year? To answer this, let us first see what her monthly salary for the second year would be. It would be Rs 8,000 plus 5,000 is equal to Rs 8,500. In the same way, we can find the monthly salary of the third, fourth, and fifth year by adding Rs 500 to the salary of previous years. So the salary of third year is equal to 8,500 plus 500 is equal to 8,000 plus 5,000 plus 5,000 is equal to 8,000 plus 2 into 5,000. RS 8,000 plus bracket close 3 minus 1 bracket close into 5,000 bracket close for the third year. So it is 9,000. And salary for the fourth year is equal to RS 9,000 plus 500 is equal to RS 8,000 plus 500 plus 500 plus 500 is equal to 8,000 plus 3 into 500 is equal to 8,000 plus 4 minus 1 into 500 for the fourth year is equal to 9,500. Salary of fifth year is equal to 9,500 plus 500 is equal to 8,000 plus 500 plus 500 plus 500 plus 500 is equal to 8,000 plus 4 into 500 is equal to 8,000 plus 5 minus 1 bracket close into 500 for the fifth year is equal to or 10,000. Observe that we are getting a list of number 8,000, 8,500, 9,000, 9,500, 10,000. These numbers are in AP. Why? Now looking at the pattern formed above, can you find her monthly salary for the sixth year, the 15th year, and assuming that she will still working in the job, what about the monthly salary of the 25th year? You would calculate this by adding Rs 500 each time to the salary of the previous year to the given answer. Can we make this process shorter? Let us see. You may have already got some idea from the way we have obtained the salaries above. Salary for the 15th years is equal to salary of the 14th year plus Rs 500 is equal to Rs bracket 8,000 plus 500 plus 500 plus 500 and up to 500 bracket close plus Rs 500 is equal to 8,000 plus 14 into 500 is equal to 8,000 plus 15 minus 1 bracket close into 500 is equal to Rs 15,000. That is first salary plus 15 minus 1 bracket close into annual increment. In the same way, her monthly salary for the 25th year would be Rs 8,000 plus 25th minus 1 bracket close into 500 is equal to Rs 20,000. First salary plus 25 minus 1 bracket close into annual increment. This example would have given you some idea about how to write the 15th term or 25th term and more generally the end term of the AP. Let's A1, A2, A3 and so on be an AP whose first term A1 is A and common difference is D. Then the second term A2 is equal to A plus D is equal to A plus bracket 2 minus 1 bracket close D, and third term A and A3 is equal to A2 plus D is equal to A plus D is equal to A plus 2D is equal to A plus 3 minus 1D. And fourth terms A4 is equal to A plus 3 plus D is equal to A plus 2D is plus D is equal to A plus 3D is equal to A plus 4 minus 1 bracket close D, etc. Looking at this pattern, we can say that the n term an is equal to A plus n minus 1D. So the nth term an of the AP with first term A and common difference D is given y an is equal to A plus n minus 1 bracket close D. Nth is also called the general term of AP. If there are m term in the AP, then am represent the last term, which is sometimes also denoted by L. Let us consider.